So this one's about the BLE Nano kit I got from Sparkfun. They were on clearance. I picked one up, figured it'd be good to illustrate in a video. BLE stands for Bluetooth Low Energy. That's a technology that was pioneered by Nordic Semiconductor. My friends up in Trondheim, Norway. I've been working with them for years in a professional manner. Great company, great products. Bluetooth Low Energy is exactly what you think. It's a version of the Bluetooth chip that uses very, very low power, so you can put it in all kinds of things. Typically, you would put it in heart monitors. I know when they first came out with it, they were selling gazillions of them to Nike shoe company. Nike was putting them in their shoes. You could make pedometers with them. They have a protocol stack called GATT, which allows the little guys to talk to each other. And so what you get is a single chip radio with a computer on it. And in fact, let's take a look at the chips here. So this is what you get with the BLE Nano kit. And I've already put the little pins on them. It doesn't come with the pins on them. I probably should have left the pins off. This is actually the little BLE Nano card itself, and the Nordic part is on the back. That's the radio, that's the antenna. This guy is a little Arduino, they say, and this is based on a Freescale ARM core. And this is probably going to be a story of trial and error as well as anything. I have a feeling one of the reasons why this particular version of the BLE Nano is on clearance because it was a bear, no pun intended, to set up. One of the things that well, let's get into that. And a little closer view of the actual board products. So this guy here is, they call it a little Arduino, and I bet it is, but in this incarnation, it's acting as what you'd call a dongle. So this guy is basically being used strictly to program this guy. So you've got two little computers here. One has got the Nordic chip on the back for the Bluetooth, that big silver thing. On this side, we have a voltage controller and a bunch of resistors and stuff, a little LED. And this one's got, and you might even be able to see the little Freescale symbol there. This one's got a little Freescale ARM core on it that under normal conditions you could use as an Arduino and you could program it as such. I have utterly failed. Despite all of their instructions on their website, I cannot make this work through Arduino. I'll show you it not working despite several hours of trying. And I am embarrassed to say nearly 4 hours of trying. And I think this is part of the illusion or delusion of open source in general. These products, people really try to get them dynamic, get them working, get them out in the market. But the software underneath them is changing so rapidly and so unpredictably that it's almost impossible for guys who make boards like this to keep up with where the software is going. Let me show you. So we head on over to the RedBear Labs website because there's probably not much alternative to otherwise figuring this out. And there you've got all the usual instructions for what the chip is. Here's some power considerations. Here's the pinouts, factory settings you can change. That's all fine and good. And what they suggest is, hey, in order to program this thing, you need to use the Arduino piece, this piece right here, as the dongle, which means that you're going to use it to load the program onto that guy there. And by the way, the best way to do that is to head on over to the ARM embed site. Okay, so here we have, see if we can get those moire pattern out of there. Here's the ARM embed website, and they've got all kinds of software support for their products, which are embedded in literally everything. ARM is the largest seller of microcontrollers in the world. ARM products are inside almost anything. I mean, anything you own, from your iPhone to your microwave oven, probably has an ARM processor in it. And they've got a really nice little environment here to program their embedded chips, their embedded cores. They actually don't sell chips. They sell what we call cores. Okay, so what does ARM sell? ARM sells cores. A core is a pattern. It's sort of like in the old days when your grandmother would go buy a dress pattern and make a dress for your sister, or pants or whatever the heck you're going to make. They sell a pattern, and you use that pattern in the design of your chip. This is an Apple A4 processor. Somebody has taken acid and etched away the black plastic package, and this shows you the silicon inside, and this piece of the silicon inside is an ARM core. It's an ARM processor. I don't know if it's an A5, A0, A6. I'm not sure which one it is, but it's inside the Apple A4 itself, has an ARM core. So it's a computer within a computer. And you buy the pattern from ARM, you use it when you're building your silicon, and then you pay them a royalty for that. And let's say this is the Apple A4. What's in here? This is, I don't know. I used to be able to just look at this landscape and tell you what it is. This here is probably a chunk of memory. There's a bunch of I/O on the outside. This is probably, some A to D's, D to A's for audio, video that go talk to your audio, video chip. At any rate, all this means something. If we had the schematic for it or a real blown-up view, I could tell you what everything was. But from this view, I really can't see. Meanwhile, if you look over here, here's another chip. This is an SEC S5PC110A01, whatever that is. I don't know where that goes. And here's another ARM core. You can tell this one looks like that one. It's rotated 90 degrees counterclockwise. You see all this stuff, which is probably memory, is over here on that one. It's over here on that one, and it's the same pattern. So ARM has sold the pattern to these two different guys, and they've used it in the development of their chip. Okay, so what does that do? That means you buy the pattern from ARM. You don't have to design your own microcontroller, and ARM provides all kinds of software support for the commercial users, but also their real, let's not say real, but real people like us, the non-commercial users. And those ARM cores are embedded in everything from your iPhones to your microwave ovens and your thermostats in your house. And so it's nice that they provide this software support. So we're specifically thinking of the embed, and we're specifically thinking of the BLE Nano kit. So the BLE Nano is based on a Nordic chip, which has an ARM core on it, and so does the little dongle. Let's remember the dongle over here. That's this piece right here in the bottom right of your screen. This little dongle is based on a Freescale version of the ARM core, and it's used specifically and only to program this. Now, calling it an Arduino, I guess it's fair because you could program it with the Arduino environment, but in fact, we're not going to use the Arduino environment to do that. There's a pre-loaded program on there, and if you change it, you can't use this to bootload this guy over here, which is the Nordic chip. Now, what we can do is, and what RedBear Labs suggests, is that you go to the embed site, you open up an account. I have already done that, and that gives you access to all of these programs that you can write in C or C++ and upload directly to your embed-based product. So again, there's a Nordic semi-chip in here and that we're worried about, and the Nordic semi-chip has embedded in it, just like that Apple core that we saw, that Apple A4. It's got an ARM core in it, and we're going to program it from any number of ways, through Arduino or through this particular environment. So we go to their website. This is the ARM website. We can write some code in C++. This is the famous Blinky program. All this is doing is, while 1 here means 1 is always true, so we're going to keep looping through this thing, and we're going to say we're going to first turn my LED, which is a digital out pin. We're going to turn it to 0. We're going to wait 1/10 of a second. Then we're going to turn it to 1, and we're going to wait 1.1 seconds. And so it's an asymmetrical blink, and I did that so I would know that if it was working, I'd see this asymmetrical blinking happen. All right, so let's see what happens. I press this compile button, and that happens so fast you didn't see it. All right, well, at any rate, it compiles and it uploads it through my browser onto my machine. Now, how do I get it onto the BLE hardware? Let's take a look at that. Now, as I was previously mentioning in the earlier parts of my little speech here, one of the problems these guys have, and probably one of the reasons this thing was on sale, is because it is a bear to get it to work. And it's not, I don't blame RedBear Labs, whoever they are. They put this nice little board together. They tried to sell it, and at the time they sold it, everything probably worked perfectly. Meanwhile, what happened? Meanwhile, Windows came out with a new version of the operating system. Apple came out with a new version of operating system. Java's been updated. You know, the embed software has been updated. Everything is changing on them. The Arduino software has changed, and everything's changing on them, and they can't possibly keep track of every environment and everything, every environment, every plugin, every module, because this thing needs a certain recipe to work. And frankly, the recipe has changed. And so I spent about 6 hours trying to get this to work so I could show you a really smooth plug-in demo. And I eventually got it to work, but man, was it hard. So the first thing we're going to do is I'm going to show you how they suggested that we do this. And you're going to see that it kind of works and it kind of doesn't, right? So what we're going to do is I've already soldered on these pins that goes like that. And again, here's the Nordic chip, the Nordic Bluetooth chip. There's a little antenna, and here's the dongle. Now, first thing you'll notice is that the USB is not the typical female USB. And this is one of the problems, or one of the interesting things about open source. The reason why things change so frequently and so often is that every time, you know, people get good ideas and they say, hey, let's try it, let's change this, let's change that. It's a good idea, it's a good idea. So somebody thought it was a good idea to not use the regular old USB micro or USB cable. They decided we're going to put the male end on there and you're going to just shove it into your computer. In my case, my computer's behind my monitor. You wouldn't be able to see anything. I wouldn't be able to see anything. So I've had to get this USB extender cord and plug it in that way. I mean, so yeah, this was somebody's great idea. It's not a bad idea. It's just really inconvenient for me, not for everybody. Okay, so we see we've got a little light there going on, so things are alive. We've got a little light on the dongle board going on. Let's take a look at the video and see what we get here. Okay, so this is just classic maker stuff, classic development board stuff, examples of how things can get all confused. And if you're not persistent and if you're not willing to put the time and effort into really trying to get something to work, chances are it ain't going to work. There's just a lot of, there are too many moving parts for anybody to keep these things working all the time in a plug-and-play mode. They're trying to keep track of Linux, they're trying to keep track of Windows, they're trying to keep track sometimes of macOS, and you know, typically the guys who invent these things, there's 5 guys in a garage somewhere trying to make some money, and it works when they deliver it, and then everything changes. On their website, they point out, actually there are blogs on their website, on the RedBear website, they point out that OS 10 version 10.10 had some problems and couldn't see their board. And now I'm running version 10.11.1, and I can see their board. When you plug in the little guy into the, here it is, hovering above Yosemite. When you plug the little guy into the USB, it brings up it mounts as a disk, which is nice. And here it is, mounts as a disk. And in fact, it's got a little link to, if I click that, I get a link to, here it is, the RedBear Lab at BLE Nano site. And I can, it's got some information about the Nordic chip, all this cool stuff. Okay, so I got to be connected to the internet to get that. And here it is saying, hi, ISO, how about logging in? I'm already actually logged in somewhere else. So you get the thing showing up as a disk. Okay, so it shows up as a disk, and what you should be able to do is go into, I'm going to go into my downloads version here, and as you can see, when you run the program on the embed site, it will upload to you, or you will download from it. It triggers a download, a hex file. This is a binary file that you load into the little dongle. This is the dongle. This here is a little window representing the dongle's disk drive. And I should just be able to just drag this over onto there, and it should just load nicely onto here. Let's see what happens when I do that. I'm gonna just let's just take, oh, for instance, let's just take this one. This is let's use the Blinky here, embedded Blinky. There we go. It's gonna take that program. It's trying to copy it, and what happens? What we find is anything blinking? I don't see anything blinking. Nothing's blinking. I can press the reset button on here. I got no blinky. Let me try to reinitialize it here. I'll plug it in again. Click. Anything blinky? You see any blinky LEDs? I sure don't. Guess what? Let's go back to the disk drive. Huh. Actually, that's the first time it's actually said it's worked. Okay, so what has happened here? The answer is nothing. I'm pretty sure that whatever happened screwed up whatever program I had on this in the first place, and I'll get back to that. But clearly, it's not blinking. Now, the light that's supposed to blink is the one here on the actual Bluetooth board, not on the dongle. There's a little light on the dongle, and it is illuminated, and it is not blinking. This one underneath here should be blinking, and it is plain not on. Now, again, those guys have the blog site says, hey, it doesn't work with version 10.10. It won't even mount the disk. It does mount the disk on mine. You just can't do the drag and drop. Okay, let's try Plan B. And Plan B, if you're using something that's an Arduino, should always be, let's go back to Arduino. All right, that's what we're going to do. We're going to go back here. Let me restart Arduino. We'll go back here to Arduino. Now, in order to get Arduino to understand that you're using the low power BLE, and this is the famous Arduino Blinky program modified, except right here I'm saying turn off the drive pin is pin P0_19, which indicates the Blinky on here. You've got to do a couple things to get that to work. If we go back up here and we just take a look at the menus, you'll see I've actually got a selection that says BLE Nano board. I went to the board manager, I plugged in a URL, I got BLE Nano driver to show up, and we're plugged into the USB modem because we are. Here we are. We're plugged in. There it is. Right? So it sees that. All that is seen. Now let's go down to the Blinky program. And what I'm going to do, I'll let this be displayed here, is I'm going to try to upload it to this guy here. I'm going to press the upload button, and immediately you see all kinds of errors. All right, these are not errors, these are warnings. So these are compiler warnings, not errors. And for those of you that are not pro software people, compiler warning does not stop anything. It just says, hey, something you've got in your program is going to stop working in the future. Now, why should that even be? Well, what it is you see here it says contains deprecated recipe or pattern. What does it mean to be a deprecated recipe or pattern? What it means is that somebody somewhere has said, you know, there's a way we used to do things, and we've been doing them that way for a long time, and maybe it sucks, or maybe it's fine, but I just have a better idea. And so they bake that into the software, and now you've got to go back and change your software. You've either got to update a library or you got to change your code, because it's warning you that the next time this happens, it's going to be an error and it will not compile at all. And what you see here is that the RedBear Lab NRF51822 has a deprecated recipe or pattern. What that's telling me is that the guys at RedBear Lab haven't updated their software since this version of Arduino came out. Now, they've got instructions about how to load everything onto Arduino 1.5. I'm using Arduino 1.6, and guess what? It doesn't work. As you can see, it compiled the sketch, but there ain't no blinky happening on here, and it's not saying success. It just sits there. I have tried everything. I've actually even tried rolling back my Arduino version to, I'm using, as you can see here, I'm using Arduino 1.6.6. I've gone back to 1.5.7. I had to deinstall my Java to a version 7. I had to back out all kinds of software just because I wanted to see it work with Arduino. It doesn't work with the new version. It doesn't work with the new Java. It doesn't work with new Arduino. Irrespective of all the libraries I've downloaded. Okay, so now we've had 2 failures, and that took me, over the course of about 6 hours. I tried everything. I could not get this to work. I don't expect you would have much more luck than me unless you're using older versions of everything. The poor RedBear guys, they did their best, you know, a year ago or 6 months ago, but this, you know, the software world changed, and there are a lot of people in the world with really good ideas of how to change the software, and they get to do it. And when they change the software, the stuff that you built that worked on the old stuff, chances aren't going to work anymore. And that's what happened here. So it doesn't work when I drag and drop into this little embed disk that comes up. And it doesn't work when I try to use Arduino. What do? Well, I discovered there are parts of the system or of the instructions that were on the blog that do work, and I have a feeling that I understand exactly why it didn't work using those other methods. We're going to use a manual method. So in order to get this guy to fly, we got to go and do the CLI, the command line interface, the Linux style command line interface, and that makes it a little difficult for people. I understand it's not plug and play. I don't know if the I suspect the Adafruit one is probably a lot more plug and play than this, but let me show you what I got to do here. All right, so what I've had to do here is type a Linux command. CP means copy, and then minus capital XV. I'll explain that in a second. Those are options for the copy command. I'm copying this file, embed_blinky rblab b blah 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 .hex. That's the hex file that came over from the embed website. So I got that hex file, and I'm copying it with the Linux copy command to my Macintosh at /volume/embed. And dot just means use the exact same name. This here option -XV means copy it without all the little accoutrements. Copy it without the flags that are Macintosh specific. Now, again, I'm doing this because I'm on Mac OS 10.11. You might be on Windows 8 or earlier and have no problem whatsoever. I don't know if it works on Windows 10, frankly. Do not know. But it didn't work what I was doing. I have to do it this way. The plug-in, the drag and drop probably does work somewhere, but it doesn't work here. All right, I'm going to execute that command. I'm going to copy it over, and you're going to see this light right here start flickering, which is a good sign. So I'm doing the copy, and it says I copied. XV -X means no accoutrement, no adornments to the file names, etc. And V means verbose, and it says it copied. We saw that thing flashing. I'll even do it again because it's not going to make a difference. You see it's flickering. It means it's uploading. Now, when I turn this over, will we see blinking? Yep, there we go. So you see the little guy blinking there, and it's an asymmetrical blink, which is what I programmed. Blink on for 1/10 of a second, off for 1.1 seconds. So we succeeded in getting a program onto that guy, and this is how we're going to have to do it from now on. Okay, now that we got through the software pain, let's mess around with the hardware. All right, so this is a program called BLE_iBeacon, and it's available on the ARM embed website. People write code. All the code winds up on ARM computers. All the code you write on the ARM website is available to everybody. There is a beacon. By the way, if you go to the RedBear Labs website, they say download this BLE_beacon thing, and you'll find it on work. Again, software revs have changed, hardware's changed, everything's changed. What you want to run at this point, on this day, which is November 7th, 2015, you need to run iBeacon with the software you get. Now, what's a beacon? A beacon is a Bluetooth program that's just going to send out an ID. It just broadcasts an ID. It doesn't really listen for anything. It just broadcasts an ID. By the way, this this silvery thing is it's a shield. It's an RF shield, so radio waves don't get in and touch the chip underneath, which would screw things up. But the chip underneath is a transceiver. It is capable of transmitting as well as receiving, and we'll show you examples of that. What we're going to use it in now is in transmit mode. We're not going to listen for anything. We're going to send out an ID. And how am I going to know that I see this thing? Well, I'll show you in a moment. But I want to send out an ID that is somewhat unique, that I know that when it is there, I will recognize it. And what I have done is I've taken this hexadecimal here, and this is the ID. This is the variable containing the UUID. And I've just changed the last couple of digits. I've made it EBEEEE. So whatever it was before, I don't remember. But when we look for a beacon, if we see one that's got characters that end in EBEEEE, we'll know it's this one, because that's a silly, that's not what it was before. So let's take a look at how to do this now. I'm going to go back to my little program here, back to my window. I've compiled that and I've uploaded it, and I'm going to do a CP -X and do it in verbose mode. BLE, thank you very much, _ iBeacon. And I've got to copy that to the little online drive here, which it has mounted on on a Macintosh. All your drives are on the /volumes, /volumes. This one's called embed, and I'm going to copy it to here. Let's make sure it copies. I click it, the things are flashing, flash, 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 flash. It's verified that it sent it. And now we should have a beacon. All right, now, how am I going to see the beacon? Well, as it turns out, I got a program, and I got it on the web. Somebody was nice enough to put a program on the web. Let me get to the darn window here, and here it is here. I'll bring it into view so you can see it. Call Beacon Scanner. All right, I'm going to run beaconscanner.app, and let's see what comes up here. Okay, for some reason getting the Bluetooth to work required me to reboot my machine, so that's what I did. Now let's see, I will hook this up now back to the USB. It will get its 5 volts from the USB. There's a little light flashing over there, and any moment now, beacon scanner, there we go, and we can see EBEEEE, the crazy ID I put in there is coming through. So it sees this. What would you use this for? Oh, all kinds of things. These little, anywhere where you want to try to figure out where something is. Well, let's see, the power one. It lost it. Who knows why? I didn't turn it off, but it will come back. There we go. All right, so why would you need something like that? Well, anywhere where you want to try to track something down by radio. Bluetooth, they say this version of low energy Bluetooth will transmit up to 60 meters. So that's like 180 feet. It's not long distance. You're not going to use it. You're not going to put a GPS in it and track a car across the country or something like that. I mean, you're basically going to locate things locally. If you want to figure out whether or not you're in the range of a keyboard, a mouse, your tennis shoes, or anything, you can, and you're not receiving the signal, you can use the beacon to figure out, gee, do I hear the beacon? Yes, no, yes, no. I hear the beacon. I don't hear the beacon. If I don't hear the beacon, then you know that any of the control stuff isn't going to work. Okay, you can Google Bluetooth beacon and figure out what's going on. Now, another thing is that I want to say is we're getting 5 volts out of this USB from a computer source. Not exactly low energy. This guy can run on 1.8 volts and just some really tiny amperage, really tiny amperage. So what we're doing here is, I'm doing it for reliability's sake, so the stuff works and you can see it working. But we're going to hook this up to a coin cell battery, and I'll show you how it works on a coin cell. But first I want to put a little more interesting program into here. So we don't need Beacon Scanner anymore. Goodbye, Beacon Scanner. And I do need my window here. And for reasons that I don't understand, I need to be in super user mode. And I am. All right, now I'm going to upload to the BLE Nano -X verify. I'm going to upload something called small v. Thank you very much. Got caps locks on. Always a problem. No, I don't have cap locks on. Downloads. Let's go there. And now let's CP minus X minus big X small v BLE, and there's only one of those, to volumes.mb. You know, the good thing is you won't have to do this if you're using Windows. I'm betting that this thing works just fine with Windows. Okay, so what we've done is we put this program called Simple Controls onto here. Now, I am going to take my iPhone. This is another one of these, another case of people who have put a handy iPhone app. So here's my handy iPhone app. And here's my handy thing. Now I'm going to connect. It turns out I'm going to connect to this guy here. And there we go. And I got a bunch of controls here. Now I am talking via Bluetooth from here to there. And one of the things I've done with these little controls here is, let's see, digital out. So the digital out pin is the LED. You can see the LED is lit for reasons I don't understand, probably because they probably have it hooked up with a pull-up transistor, which means that when the digital out is low, the light goes on. Now I'm going to turn the digital out to high, light went off. See, light went off. Turn digital out to low on that pin, the light goes on. Turn it to on, the light goes off. So you can see I'm actually talking to that. Now there's a digital in, there's pulse width modulation, there's an analog input, and I'll show you those things working. But first let's switch to a coin cell battery, because that's what low energy is. If you had to walk around with a USB plugged into your sneakers, that would, or your heart monitor, that wouldn't be too interesting. But if we put a coin cell battery on this and we only use this piece, this thing without these pins could be pretty small. You know, pretend the pins aren't there. This thing could be pretty tiny, and you could put that into all sorts of stuff. So, all right, let's go hook up a coin cell battery to this. Okay, because we're nerds and we need to know these things, I am just going to try to find out what's the voltage. So we got like 2.6 volts. Let's see if we can hold it. Yeah, somewhere around 2.5, 2.6, 2.7 volts coming out of this crappy battery here. So this is a old used coin cell Chinese battery. It's not an ever ready or anything like that. God knows how many amps it's capable of supplying, probably maybe less than a milliamp. And now I'm going to go over with my iPhone here, and I'm going to connect to that guy. And now we're connected to him. Let's see if I can keep everything in focus and together here. And what I'm going to do is, the light is on now. Let's see if you can see the light is on. And through the magic of the iPhone, there we go, the light's off. And now I'm going to switch this switch, and it goes back on. Okay, that's pretty cool. With the coin cell, I can turn the thing on, off, on, off, on, off. But what else can I do? Well, I can actually control motors. And what I'm going to show you is let's do this. Let's see if we can get the analog in to show anything. All right. I put the meter in ohms measurement mode, which means it's applying a little bit of voltage there. And I'm just going to touch it to the analog input pin, which is the third one down here. Oh, first I got to turn it on. Okay, so it's reading noise now. And if I touch this to that pin, see how it goes up 600 and something. So if I take that off, it goes down. It's just noise, 176. So you can see the analog input pin, and I'm looking right there, is sensing that little bit of voltage I'm putting on there through the meter. Okay, so that works. Let's do the pulse width modulation. Okay, so here you see we're getting a pulse width. We're getting a pulse out. It's kind of noisy. Yeah, you know, we're running at what, 2.5 volts, and gosh knows how many tiny amps. I could probably measure the amperage, but we know that it's microscopic. It's got to be under a milliamp. So if I bring the iPhone here, can you see What I'm going to do here is I'm going to narrow the pulse width by moving that, and you see the pulse narrows even further. Go a little further on that. See, my fingers are kind of big and fat. And let's see, I can even narrow it further. There he goes, even having trouble triggering on it. Let's widen it up again. There we go. So yeah, we got a little bit of noise there, but you'd expect that from such a low energy device. It's probably picking up, you know, there could be radio noise from any of the sources here. And let's just go back and take a look. There it is, looking like some biology experiment we did when we were kids with the poor little frog. At any rate, that's what I want to tell you about Bluetooth Low Energy. This is the RedBear Labs kit that I got off of Sparkfun. There are many of them out there. This one is particularly hard to use with the software that's out right now. It can be done, as you see. You can, if you're using Windows or Linux, you don't have to go jump through all the hoops I did. And especially if you've got older versions of things, it probably works just fine. I bet the Adafruit one also probably works just fine. At any rate, you get the idea. You can use a coin cell. You can talk up to 180 feet and transmit data, transmit a beacon, and you can do all sorts of things like that with that. Heart monitors, pedometers, those things you put on your wrist that tell you how far you've run and stuff like that, and talk to your computer. That's what they're doing. They're using this low energy Bluetooth stuff, and you can play with it too. Anyway, I'm Joe. If you learned something from this and you appreciate the energy I put into it, please give me a thumbs up. I'm going to keep trying to do these development platform videos. Somebody suggested I do the Parallella, and I'm really interested in doing that. That's an interesting, there's a 16 processor version of a circuit board with, I think, 16 ARM cores. Actually, it's a special purpose processor. It doesn't have ARM cores. They designed the board themselves. I might try to do that. The board's kind of expensive, but at the end of the day, what I really need is an application that I can show that requires running up to 256 parallel computers at the same time. I could program it. I just got to figure out what I would do and how the video would look. But that may be coming up, the Parallella. I've got another couple of these things coming in from Sparkfun, and I'll keep doing these videos if you keep liking them. I really appreciate it. I put energy into it, and I'm getting some good feedback in return, and that's what it's all about. I don't do this for money. I've got other things I do for money. I'm doing this because I enjoy it, and I want to contribute back. So please give me a thumb up or down, subscribe if you like it, and thank you very, very much for watching.